what is our subject? We analyze circuit analysis or network analysis, right? So what is meant by analysis? We need to find out the voltages, the currents of various elements, or the power absorbed or delivered. This is the basic idea of circuit analysis, right? Now, in order to do the analysis, we will be needing some circuit techniques. Once you know these techniques, then analyzing a circuit becomes much more easier, or it might be much more simpler. Okay, so we will start with the techniques. We will start learning various techniques. Okay, the very first one is the equivalent voltage and current sources. That means if current sources or voltage sources, they are connected in series or parallel, then how can we replace with an equivalent source? Okay, now firstly, what is series and parallel? When you say that some circuit elements are in series, they are connected in such a way that the currents through them is equal. Okay, so you can see that whatever current is passing through this circuit element, same current will pass through this, same current will pass through this. So this is the series connection. Same current will flow, right? What about parallel? In a parallel connection, we have the same voltage across all of the elements, right? Since both of the terminals are connected to the same point, then the voltage across them will be same. Same voltage will be present. Now, if you take the sources, first we will consider voltage source. Now, when a voltage source, it is connected in parallel, when number of voltage sources are connected in parallel, then care has to be taken that all of the voltage sources have the same value. Okay, because when they are in parallel, so first we will consider the parallel connection. So parallel means the voltage should be same, right? So all of them should have the same voltage. If they are not having the same voltage, then they might get damaged. So you can simply replace with a single equivalent voltage source. How many ever voltage sources of the same magnitude you connect in parallel, it is going to be equivalent to a single voltage source. There is no difference there. Okay. What about a series connection? In a series connection, what is going to happen? So we will take, in the example, we will take 3 voltage sources. Okay. So this is giving V1 voltage, V2 voltage and V3 voltage. Then we need to represent it with an equivalent voltage source. Then what will be this voltage source equivalent to? VEQ. Okay, so you can see here that this entire, the polarity we have taken plus here on the left hand side, negative here. So if you take this to be VEQ, then what will be the voltage across this entire branch? So you can simply apply the KVL. Okay, so what will you get if you apply like this? Then V1 plus V1 plus V2 minus V3 minus V equivalent is equal to 0. This means that V equivalent, you are going to get V1 plus, this is V2. V1 plus V2 minus V3. Okay, so you can write here V equivalent is equal to V1 plus V2 minus V3. What about if we reverse the polarity? That means for the same connection, you want to replace with an equivalent voltage source which is having negative polarity here and positive polarity here. Then what will be this equivalent? This is equal to just the minus of the previous one, because nearly the same thing, only just interchanging the terminals, polarity. So this is going to be minus V1 minus V2 plus V3. Okay, so be careful of what is the polarity that you are using. So another simple way of remembering this is, here if you take a positive sign, the left hand side, whatever has the same polarity, you're going to take plus V1 plus V2, and V3 has opposite polarity, so minus V3. Okay, so you can simply remember like that instead of applying the KVL and then writing the expression. Okay, so this is the voltage sources when they are connected in series and parallel. Then what will be the equivalent voltage source? How we can represent with an equivalent voltage source. Next we will discuss the current source, equivalent current source. Now the current source, if they are connected in series. So in a series connection, how the series connection is going to be? The same current will pass. So the same current should pass. Then what about these current sources? All of them should carry the same current. Care has to be taken. Otherwise the source might be damaged. Okay. So you can replace simply with a single equivalent source. What will be the current? Simply I. Okay. So this is the series connection. Just like in a parallel connection of voltage sources, you have to connect the same voltages, and the equivalent voltage source will simply be the same voltage of individual source. Similarly, in series connection of current sources, you are going to get the same thing, same result. In parallel connection, what is going to happen? So here the currents are going to get added up. So let us say this is the current source, this is one current source, taking three current sources. You can take more than three as well. Okay. So this is I1, I2 and I3. Okay. So now this is the parallel connection. Now how will you replace with equivalent current source? So here also you should take care of the arrow. Okay, so now the arrow is in the upward direction. You can apply KVL here. You need I equivalent current here, right? So here you need I equivalent. If you apply KCL, then you're going to get the expression for I equivalent, which you can also simply write which you're taking direction in the upward direction. So whatever is in the upward direction you will take positive, whatever is in the opposite direction you will take negative. So I equivalent is equal to I1 plus I2 minus I3. If you're taking in the opposite direction, then simply I equivalent is equal to minus I1 minus I2 plus I3. So in general, if you are taking n number of voltage sources in series, parallel we don't have to discuss, because how many number of voltage sources in parallel, it is going to give the same result. Then what will be the equivalent voltage source? You have to use the appropriate polarity. Then this you can represent as V equivalent is equal to simply the sum, algebraic sum. Okay, Vn. Similarly, when you have n number of current sources in parallel, okay, then connection, let us say this is I1, I2 and like this you have In. Okay, then you can represent with the equivalent current source, which is the algebraic sum of all of the individual current sources.